Hello everyone. In this video we are going to be solving this problem. BAC is a sector of a circle, center A. AC is 10 cm. Find the area of the shaded segment. Give your answer in terms of pi. This is the diagram. We would see that this diagram here is a sector of a circle. How do we know that it's a sector of a circle? The previous video I made on the parts of a circle, the link is right here at the top right hand corner of the screen. We would see that since this is the center of the circle, now automatically this surface, this curved surface, is called an arc, which is a portion on the circumference that's less than half of it. So that makes the line AC to be a radius, because a radius is a straight line that runs from the center to the circumference, and also AB is also a radius. So we find that the entire shape right here is bounded by two radii and the arc. So this is called a sector. Okay, so we also see that this shaded region from the initial diagram is the segment, because from the last video I defined the segment as a portion within a circle that's bounded by a chord and an arc. So this is the shaded region the question is asking us to obtain its area. So we see that the entire shape, which is a sector, incorporates two shapes. One is the segment, this shaded segment right here, and the other is the triangle ABC. So this is triangle ABC. So triangle ABC, ABC. So our interest is to obtain the area of the shaded segment. So what I just have to do here is to make the segment the subject. Therefore, the area of the segment is going to be the area of the sector minus the area of triangle ABC. Okay, so the next thing is to obtain the formula for the area of a sector. There are two ways of working out the area of a sector depending on the angle the sector subtends at the center. If the angle is in degrees, the area of a sector is theta over 360 times pi arc squared. But if the angle is in radians, the area of the sector is theta over 2 r squared. So we can see here that the angle here is in degrees, 60 degrees. So we are going to go with the first one. Therefore, we would say that the area of the segments equals area of sector, which is theta over 360 times pi r squared, minus, now this is the triangle. We've got several formulas for the area of a triangle, but here we would see that this triangle is an isosceles triangle because we've got two equal sides. So the appropriate area of the triangle is going to be 1/2 multiplied by the two given sides here, that's AB and AC, multiplied by sine of the included angle, that's theta. So the area of the triangle here would be 1/2. AB is r, AC is also r, that's going to be r times r, so this is just r squared, then the sine of the angle. So already we can see that the radius is 10 centimeters. We have established that already. The angle subtended by the sector and of course the segment is 60 degrees. We are asked to leave our answer in terms of pi, so pi is just going to remain as pi. Pi is just pi. So these are all of the parameters we need to obtain the area of the segments. So I'm just going to substitute this. So theta is 60, so this is 60 over 360 degrees times pi times the radius is 10 cm, that's 10 squared because we've got arc squared here, then minus 1/2, radius is 10, so this is 10 squared, multiplied by sine theta, that's sine 60 degrees. Okay, so we can reduce this. 0 can make way for 0. 6 here, 1. 6 in 36 is 6. Now 10 squared is 100. So this is 100. So 6 can also reduce 100. So 2 in 6 is 3. 2 in 100 is 50. So I'm done with this part. Now 10 squared also 100. So 2 can reduce 100 50 times. So what I have here is I've got 50 pi at the top, then a 3 underneath, minus, now here what I have is 50 sine 60. So this is 50, and we know from our special angles that sine 60 is root 3 over 2. So this is times root 3 over 2. Okay, so 50 is common here, so I can just decide to factor out 50, and I'm going to be left with pi over 3 minus 3 over 2. So I can leave my answer in this form, or I could just take the LCM of the denominators. That's going to be 6, and this is going to be 2 pi minus 2 in 6 is 3 root 3, and of course I can just reduce 6 by 2 and reduce 50 by 2, that's 25. So my final answer can be 25 over 3 into 2 pi minus 3. Now this is a measure of the area, and since this unit is in centimeters, so I'm going to have centimeter squared. This is the area of the shaded segments. I hope you found this video useful. If you did, kindly like, subscribe, and share it. Thank you for watching. See you in the next video. Bye.